All right, you people, listen up. Okay, so today we're actually talking specifically about, hey, similarity.
Hey, you guys be quiet.
I know, children, come on now.
You guys are sophomores now.
All right, so a lot of things that actually go along with this. Definition. This is almost like, hey, there's a definition of something here that might be good in my handy dandy notebook, which is going to be helpful for me later on.
Oh my goodness.
Did you write similarity on it? Did you open it up and it has a picture of like two dogs?
2 cats.
Is that one it?
No.
Oh, okay, then it's not that one.
Dog.
Yeah, there's two dogs in the.
When did you guys
It's
do
like
it?
the second slide. Mine's right here.
When did you guys do it?
It was Tuesday last week, my dude. So right here.
Oh, I wasn't here.
I
Okay.
haven't, but I'm so lazy to go through it.
Yeah, you guys are gonna have to wait for Miss Amanda to actually get back.
You talking about that one? I think
Yes,
you
this
want this one.
No, this one.
Bro, I'm not gonna look, bro.
Bro. Oh, I'm sorry. Did I inconvenience you by asking you to look for your stuff?
No, you finessed me.
I'll look for it later.
Okay, thank you. All right. So right here, this is important. Definition. Hey. Definition. Similar polygons have exactly the same shape. Same shape, but can be different sizes. Specifically, two polygons are similar if two things are true. Similar. If corresponding interior angles are the same, congruent, so if the angles are all the same, resulting in the same shape. Corresponding sides of each are in the same proportion, same ratio or scale factor. Proportion, ratio, okay, proportions, just like we have here. So, what does it mean for two shapes to be similar?
Have the same angles.
Have the similar shapes have the same, but do not have the same.
They have the same congruent, but don't.
The same. What?
But do not have the same.
Listen.
I thought it was the opposite side from that angle.
No. They have the same angle, so all their angles are going to be the same. Hey, shh.
What?
Listen, Candyman.
Then you call it candy band.
I'm enjoying it while
All right. Next one. How is this different from congruence? Congruent shapes are the same blank and blank.
Shape and size.
Shape and size.
Good job.
What transformations led to congruent shapes? What are the rigid transformations that lead to congruence are? Reflection.
Rotation.
Translation.
Rotation.
And rotation. Very good. Shh. Why are you still talking? Seriously. All right. Dilations. The next part. Dilation occur when you multiply both x and y coordinate by a scale factor. Okay, so we're going to talk about on a coordinate plane here now. Any rigid transformation still has similar shapes, but dilation leads to similar without congruence. That means that they're going to be different sizes. So, here's a horizontal stretch. Now, if I'm looking here, let's see, x comma y, so let's start with this one right here. X comma y, so this is going to be 1, 2, up 1. So it's going to be 2 comma 1. So that's going to be located at 2 times the x is 4, comma and whatever the y is, 1. That's what a coordinate rule does.
I didn't know that.
Okay, so let's look at this next one. This is going to be over 1, up 1, 2, 3, 4. 1, comma, 4. So what is this one going to be? Wow, it got quiet in here real quick. It's going to be 2, 4, right? Because it's 2 times the x value. Very good. Because I know there's no one in here, especially in the front row, sitting in with earbuds in. Because I know they're paying attention. Right?
Of course, why not?
I know, right? And next one is going to be, let me see, 1, 2, 3, 4, 5, up 1. 5, comma 1. What's that going to turn into? What's it turn into? I heard it.
10-1.
10-1.
She said it.
Muy fácil?
Oh, you use times it by 2.
Yeah, that's what we're doing. That's what it said. Okay, so this is a stretch. Listen. Excuse me. Hey, you two, stop talking to each other. I'm trying to give you guys answers for this. Horizontal stretch only does one of them. Okay? Over here, dilation has them both the same. Both x and y by the same scale factor. What is the scale factor here? Say 2. The scale factor is 2. It says both x and y coordinate by a scale factor. The scale factor here is 2, isn't it? That's what I'm talking about. So the scale factor is 2 for what we're talking about here. So now let's do this one. So this is going to be, let me see, -1 down 2. -1 and -2. Let's see if I could actually get them all here. So -1, so it's going to be 1, 2, 3, -3, -2. Next one's -4, -4, -3, and my last one is going to be -1, 2, 1, 2, 3.
Negative what?
Which one do you need?
The last one you just said.
-2, -3. Okay, so here's my dilation. So what is this one going to become?
A 1. -1.
In -2, right?
Yeah.
Because it's 2 times that number. So it's -2, comma, -4, right? Because it's 2 times that number. And let's see if that works. So it was right here. -2, -4. Let me see. 1, 2, 1, 2, 3, 4. Hey, look, it is right. Okay, it works every time. So if you multiply this correctly, you should be good. All right, let's do the next one. Help me out.
-9.
Negative and
Oh, you don't divide?
-4.
yeah, you are multiplying. So 2 times 3 is going to give you the 6 part. Okay. Next one. -8 and -6. Last one. -4 and there we go. Is that pretty easy now?
Of course.
Okay, so this is basically the definition stuff that you need for this. This is going to be very, very helpful for you. So, now, here is from Similarity. We have scale factor here. This is from my handy dandy notebook here. Okay, Similarity. Okay. All this stuff is actually stuff that you need, so. Alright. So, don't forget, like, subscribe. This is page what in the notebook?
65.
65.
What is the